Now in FT NMR, it's different than CW in two ways. The radio frequency and the magnetic field are different. So in FT NMR, we keep a constant magnetic field, which it turns out is much easier to do than varying it. And it's much simpler to vary the radio frequency. So if we look at this first panel, we can see we have a proton. It's a naked H atom, and a naked H atom with an external magnetic field of 14,100 Gauss processes at 60 megahertz. So at 60 hertz on the operational frequency, burst comes in, hits our proton, and we see absorption. Now, most of the time, we have hydrogens that are in chemical environments with bonds and connected to carbons, and carbons connected to halogens and all sorts of things. So we have an electronic environment around those protons. Electrons move around, and when they move, they generate a magnetic field. So over here, let's shield our nucleus with an electronic cloud, right? And so let's just say, for the sake of doing this problem, that shielding causes a loss of 10 Gauss. So our outside magnetic field is kept constant, remember, with FT NMR. So our incoming frequency here comes in, and it doesn't couple right off the bat, because at 14,090 Gauss, we have a lower B inside, which means that we have a lower frequency of precession. So that incoming frequency can't be 60 megahertz anymore. It needs to be smaller than that, or lower. And that will show up over on our right-hand side when we look at our NMR spectra. So some of the terms that we saw in the other description of NMR axis with CW are still present here. So you have shielded over on our right-hand side, de-shielded over on the left, downfield, same place, upfield, the same place. And the only thing that's different here is that when we talk about FT NMR, we're going to be talking about frequencies. So we have a higher resonant frequency over here on our left-hand side, and a lower resonant frequency over here on our right-hand side. And so if we're more shielded, as we saw up above, right, we remove some of that external magnetic field, and that causes our frequency to be lower, which means that our operational frequency also needs to be a little bit lower. So, right, a lower resonance frequency here.